Hello, welcome to Quantum Leap. Today we are going to discuss conservation of energy work. The total amount of work done by the force acting on various particles of systems from an initial configuration 1 to final configuration 2 is given by work equal to F into displacement dr. So this force can be split into two terms. We already know one is external force, another one is a internal force. Here I not equal to say this is equation number 1. The kinetic energy according to the Newton's second law F equal to ma, this is F equal to ma. Then we need to try to substitute Newton's second law here. So after substituting Newton's second law, so in place of S, no, Newton's second law, in place of dr, v into dt. So this is our derivation formula. So then you will get this one. Now differentiation integration going to cancel, then you'll get kinetic energy of the system. This is our kinetic energy. Therefore, work is equal to kinetic energy of the system. Work done by the force expressed in terms of the kinetic energy. This is very, very important. This is also known as the work energy theorem. Now, similar type of equation I'm going to extract from the potential energy, like W1 to equal to T1 minus, sorry, V1 minus V2. So I need that formula. So potential energy. So in potential energy, the external and internal forces both are conservative and derivative from the scalar potentials. So this is our work F dot dr. Simply we are expressing force in terms of potential energy. So if you look at this one, so we already know this one. Force can be expressed in terms of external force and internal force. So here I'm going to try to arrange force in terms of potential energy. That's it, nothing else. So force can be expressed in terms of potential energy, and we can write the potential energy this type of form. And here the one more potential energy is there. This is the Fij. So minus del I Vi. I mean del I Vij. And this interaction, we should consider two type of interaction here. Force, this internal force ij and ji force. So if you want to try to write this one, use here minus, I mean fji, interchange these terms, then you'll get minus del j v ij. Okay, this is equation number 3. So here try to derive these things. Simply the position vector r can be expressed like this. We already know this one, and another position vector, this one. So the difference between these two position vector, this one, and the modulus of this position vector of this one, or else we can write this one. We already know formula, this one, r I j. So I'm going to write this type of. Now you try to differentiate this one with respect to the x, y, z. You will get the different type of information. So this is this one. This is the main important formula. Rij equal to root of xi minus xj square plus yi minus yj whole square plus zi minus zj whole square is there, right? You just differentiate this thing with respect to x one time, you'll get this type of thing, y and z also. So if you look at carefully here, root of this thing, so in place of here we are going to use rij. So after using denominator value, or I'll get 2 gets cancelled. So similarly, if you try to derive with respect to y, you will get this one. Okay, this is equation number 5. And similarly, you try to derive with respect to z, you'll get this one. This is equation number 5. And try to rearrange these equations forms like this in terms of potential energies. So dou v divided by dou x equal to, I'm going to write like this. So dou r going to cancel, then you'll get. So I know dou r divided by dou x value. This one, right? Equation number 4. If you use this information here, then you'll get this type of equation. This is equation number 7. Very, very important. Similarly, you can derive uh, y coordinate and z coordinate also. This is y coordinate equation. This is z coordinate. Okay. Just rearrange this equation like this. You'll get 3 different equations. Now you try to substitute this equation 7, 8, 9 in equation number 3. Okay, this is our equation number 3. We already know this force, internal force can be expressed in this form. So then I rewrite this one. We know del can be expressed dou by dou x plus dou by dou y dou by dou z, right? So I know dou v divided by dou x, dou v divided by dou y value. So if you want to look one more time, just look at here. Dou v divided by dou x, dou v divided by dou y. So just I need to replace these values in this equation. Just replace. Okay, you will get this one. This is v dou v by dou x value. This is dou v by dou z value. Then rearrange this equation. Common term is dou v by dou r, 1 divided by r. This is common term. So we know this equation. This is a difference between the two position vectors ri minus rj. So I try to arrange this equation like this. I got this type of equation. So this is very, very important equation. So similarly, we are going to derive f j I term also. Okay, just follow the same procedure. You'll get this equation. Then you need to try to arrange these two equation fij, as it said earlier, uh, force ij, force ji also there. Just rearrange this information here, then you will get this formula. Okay, then minus common is there. If you arrange this formula, finally you will get final information fij dot dri equal to minus summation of del ij vij dot drj. So this is the our formula. Force can be expressed in terms of potential energy. Just replace the fij value fie, I mean external force, internal force. This is internal force information. This is external force information. Okay, and just put these values here. Simply external force this one, internal force this one, and rearrange the equation. Rearrange means there's integration differentiation going to cancel, right? Which means here del means dou by dou r. I mean dr, right? Dr, they are going to cancel. Integration differentiation going to cancel. Then only v is there. Minus is there common. Then v potential energy is there. Here the limits, upper limit is 2, lower limit is 1. So therefore I got this equation. Okay. V2 minus V1 is equal to W. So here the potential energy is Vi plus Ve. This indicate the Vi means external potential energy. This one is the internal potential energy. So potential energy means always we're taking internal potential, external potential, right? So similar type of equation what we got in terms of force. So this is very, very important. From this information, we'll get the work energy theorem. T2 minus T1 equal to V1 minus V2, T2 plus V2 equal to T1 plus, this one is T2. Okay. Okay. T2 plus V2 plus T1 minus T1 plus V1. So therefore, T plus V equal to constant. Kinetic energy, potential energy is equal to constant. Hence, the conservation of energy theorem is proved. So, uh, this topic is end here. Just I am going to give one more explanation about this potential energy. This is very, very important. So, my conclusion of this potential energy term is so like this. Especially, I'm going to talking about this one, potential energy of second term. The second term on the right side in equation will be called the internal potential energy of the system. In general, it need not to be zero, and more important, it may vary as the system changes with time. Only for particular class of systems known as a rigid body will be internal potential always be constant. So rigid bodies are always say the potential energy, I mean the distance between the two systems, I mean two particles distance must be fixed, right? That is a rigid body. So a rigid body can be defined as the system of particles in which the distance, I'm going to give distance rj term here, the fixed and constant, it cannot be vary with time. That is a rigid body. In such cases, the vector drj can only be the perpendicular to the corresponding r ij, and therefore force also. Therefore, in rigid body, the internal force do not work, and the internal potential must be remains constant, since the potential is any case uncertain within the additives constant, and unvarying internal potentials they can be completely disregarded in discussing the motion of the system. So this is my explanation. So if you want to follow this information, you need to follow three books. One is Goldstein, another one is J.C. Upadhyaya, another one is um, S.L. Gupta, Sanjay Gupta, BSc Physics textbooks. Thank you.